So I'm just going to use a malicious document generator to create a document. So you can get that from here. Just a minute, and dig through. Okay, guys, so we have a script, a Python script that we can use, guys, to achieve it. So you could go to Logbyte and download the script and go to Logbyte. This you can on GitHub to download the script. Then you can run the script on your what's it called, your lab. So I have downloaded the script. You can see this is it, CVE-2021-40444. So I'm just going to change directory to the script, and you can see you can see the exploit script. So this exploit.py is a Python file that can be used to generate a malicious document. So what I'm going to do is that I'm going to generate a malicious document. But before we can generate a malicious document, I would like to also state that for this test, our ActiveX Control will be using a sample DLL file to replicate, to demonstrate our malicious ActiveX Control. So we'll be using this file called cscl.dll. Is a dynamic library file. It's also a legitimate file that exists within Microsoft, and it is used to it contains program that can be used to execute Windows calculator application, right? So that is what we'll be using for the test, because we don't have the original what's it called, the original malicious DLL file that was used during this attack. So we'll be using this instead. So like I said, once you download that particular file from GitHub, it contains all the necessary files and information that you need to carry out this attack. You can see this is where we have the test. So we have the DLL file. You can see this is the DLL file. This dynamic library file, like I said, contains instructions and programs that can be used to execute window application, calculator application. So this is the DLL file that will be attaching to our documents, and we expect that when users open that document, open the documents, it will spoon up run DLL32.exe, which will now open up window calculator. So this, once the document open, we expect that we get these applications, the window inbuilt calculator open up just like this. So this DLL file is what runs and executes the window-based calculator. So for this POC, we are trying to depict and demonstrate how the malicious MSHTML file works. So the first thing, like I said, is that the attacker will want to create a malicious document, and that's what we are going to do. So let me move back to where we have the exploit file, as you can see. So then I'm going to run, because it's a Python file, right? You can see, guys, it's a Python file. So I'm going to use Python, latest Python version 3, guys. So I'm going to state the exploit, right? I'm going to state the exploit, then I'm going to put another keyword called generate, right? Then I'm going to state my malicious ActiveX DL file. So like I said, in this scenario, we are using the executable file for window calculator application, which is the cscl.dll file. So I'm going to state it over here, slash. So it is located within the text folder. So I'm just going to put test test slash CACL co.dll. So what this script will do is it's going to imbibe, inject this DLL file within the Microsoft document and generates a malicious document for us. So also I'm going to state the URL, the malicious URL, so which will be the IP address of my server, which is serving as CNC, right? So I'm just going to do this. 192, so my IP address is 192.168.8.100, guys. So you can see we have our payload. You can see, guys, you can see we are creating a Microsoft remote code execution payload. You can see this is our URL. So you can see the malicious payload there. If you scroll down, you can see that the file is completed. You can see malicious document payload generated, and look at it is located within the out folder. So we'll just go through. Let's go into the out folder. So change directory to the out folder, right? And you can see that we have the document for it. So the next thing we are going to do based on this attack keychain is that, like I said, the attacker delivers the malicious document, to victim via phishing, so this is where the attacker tries to convince the user, or is the victim or the target to open that, what's it called, that malicious document. So most of the time, this will be done via email, sending phishing email or spear phishing email, to fear phishing attack to corporate bodies or to several individuals to open that document, right? So at this point, we are going to copy that document to my system, to my target system. So this is where it is located within the out, guys. So we're just going to copy this and let's see. So guys, I'm going to copy it, and but you can see, so at this point we're demonstrating that the attacker has sent a phishing email and I have downloaded the documents, right? So at this point, like I said, we are going to also, during this POC, we are also going to be monitoring the activities that within this vulnerability, what happens underneath, how to detect and find out the best way to mitigate against it. So one of the tools I will be using is a process monitor. So we can see once a user actually opens up that document, what will happen. But before we also, so I'm just going to try and close up. Okay. Okay, so before we go on to open the document, we need to set up a listener on our server. So we are just going to set up a listener on our server, and to do that, okay, just a minute. Okay. So we are going to set up a listener on this server using on port 80. So Python. I'm going to use sudo Python 3, Python, then the exploit, exploit.py, then host 80, port 80. Okay, so I think we are okay. We are not in the directory. We have to go back to directory. So let's check. Okay, this is where the Python script is. So we're going to host. Okay, so you can see we have host a server to listen for any victim that tries to open that application, so that we can establish, so that first of all we can download the malicious payload to that victim system, right? So that it can further infect the system with other malware. So this is our server that we've hosted. So it is just depicting a CNC server, right? So on within the wide, in the real life scenario, guys, attackers will use covert strike, right, to do this, to host their CNC server. So I'm just going back to the target machine, right? Then we're going to spin up process monitor so that we can monitor for activities that are happening. Yeah. We can monitor for activities that are happening within once the user tries to open the document. So at this point, I'm going to open this document, then we can start monitoring for what is happening. Okay, guys. Once you're trying to open the document, let's take a look at before getting. You can see there are several processes. You can see, guys, it's contacting the server for information. It's trying to contact the server. So once you are opening the document and you're getting this kind of alert, guys, so getting this kind of alert, you can see even my antivirus detects these, right? So because there seems to be like a connection to the CNC server outside, you can see, you guys can see also. So at this point, you can see, I'll try to disable my antivirus because I noticed that the antivirus did not allow the winword.exe, that is the executable file that is hosting our Word document, to spin up the Windows calculator application. So let me just go into so I'm just going to disable these. I thought it was disabled earlier. Apparently, okay. So guys, we run that. I'm just going to close these. Yeah. So I'll try to, so that we can get all the information. So you can see, guys, even though we didn't see the window calculator application, we can see that we got a connection back to our server. So I'm just going to stop this and rerun it. Yeah, I'm going to clear this up. Let's see. Just a minute. Okay. So I'm just going to so this process that I'm going to start it over. Okay. So guys, okay, so I'm going to start this over, guys, and I'm just going to okay. So you can see that our antivirus have deleted the document file. So I'm just going to recopy that document back to our victim machine. Okay, it's located here. So guys, this is how it is. But like I said, with in the real life, attackers will try to use phishing emails, right, to deliver these malicious documents to their victim and get to convince their victim to open this document. So I'm just going to open up the process monitor once more so that we can monitor for this activity. Okay. So guys, so currently what I've done is that so that we can streamline our process, what I've done so far is that we are going to monitor for okay. So I want to, so we are going to create a filtering process. You can see, so we are going to monitor, we'll create a filter to monitor only for winword.exe because, like I said, we are opening the Word document. So, because if we monitor for the whole process, there will be so much processes. So, in order to streamline just for what is happening when we open the Word document, we are just going to filter. So, the way to do that is to just go on here to click process monitor, then put in your winword.exe, just like this, right? Then you click on add and apply. That is what I just did. So currently what this means is that it will be checking for activities, process activities for winword.exe. So I'm just going to click. Yeah, so okay, so I'm just sorry. Okay, so I'm just going to click OK. So right now, I'm going to run again, like I said, the application, the document. So whenever you open a document, try to make sure you pay attention to the process, the activity that happens as it's opening. You can see what happens there. User control. You can see it's trying to open up document. You can see that it has spun up CMD. We can also see that just spun up CMD and it spun up CMD twice and it opens up the window is inbuilt calculator, right? So this is the expectation based on our document, right? So this is depicting what will happen, just like I showed you guys. This is a capture of what was gotten from the MSHTML vulnerability. Is a capture of the file. So when a user click on the enable editing, what will happen is just what we've just seen now. It's going to spawn up legitimate window processes, and it's also going to run some libraries, malicious code, on the within the at the background, to establish connection back to the CNC server or infect the target system with more malwares, as you can see. So this is a very weird process behavior. It is not expected. It is not a legitimate behavior. So when we have Word documents opening up application, it is something that we have to check and make sure that we investigate what kind of applications are dropped at the background. We have to check that's why I open up the process monitor so that we can see what has happened within the background. Okay, so guys, you can see that we only filter for winword.exe. So we are just going to take a look at what is happening on the background. What we notice is that when we open the Word document, it spun up cmd and cmd.exe, which also spun up the the window calculator application, right? So let's take a look at some of the information that we can gather from the process monitor. All right, so the first thing we can notice is that we are going to take a look at, and also let us check our CNC server to be sure that we have a connection. So you can see, guys, this is what happened when we open the document. The first thing was that there was a connect. You can see there's a connectivity from the victim machine back to the CNC server. And the first request that we have here is that once a connection was made, we notice that word.html and HTML file, you can see, just like I explained from within the attack keychain, that once the user click and enable the editing button, the exploit will load the HTML file by using MSHTML protocol to open the URL, guys. So that is what we saw from this part. You can see the word.html file, right? So once the user open up the document, what is expected at the malicious ActiveX control, we try to request you via the URL to get the word.html document file from the CNC server. And as you can see, the next thing is that you see there's a get request for the word.html file. So once this is received by the victim machine, the next thing is that it's also going to request see. Okay, you can also see we also have a .cab. This is a .cabinet file, basically used to archive a file. So we can see that there's a .cab file also noticed here, which is which was not there was a request to get this .cab file, but this request was not successful. This request was not successful. So let's take a look at what happened within the process monitor and why request was not successful. So you can see the first thing that happened, guys, was that winword.exe, which is executable file for Microsoft Word, starts once the user click to start a process. You can the Word document, the winword process starts, and once that starts, the next thing is that there's so many requests to create files. These are legitimate DLL files, you know, within the Word document. So we are also going to take a look at, if there's a TCP connection to an external URL. Let's try and scroll down. Okay. You can see so I think we're just going to filter because there's so many files here. Take a look at what's happening. Okay, guys, so I think I will just add a filter that we can get to see the information. So I'm just going to add. Okay, so let's take a look at the process tree. I think that will give us better information. So let's take a look at the process tree. Okay, guys, so yeah, we have, this is the process tree. Okay. So I'm just going to scroll down. So you guys can see that we have winword.exe. So we can see that winword.exe, which is the executable file for Word document, tries to so let's take a look at the command. Okay, so guys, you can see just underneath, yeah. So you can see winword.exe, spoon up control.exe. Control.exe, guys, is the executable file for control panel. So the question is, this also seems to be very malicious. It's unusual behavior, because why would winword.exe spawn up control.exe? So you understand my point. So once we see this kind of behavior, this kind of we need to investigate this file, because it's showing a malicious behavior at this point. Because when you open up a Word document, it should not spawn up control.exe. As you can see, .cpl, this just shows that it's a control panel file, right? So we can also see that run DLL file is executed. So you can see that run DLL file is executed by the control panel file. You understand? And if we scroll down, we can see several repetition of this event. And if we try and scroll down to see if there's any other information, you guys can see at this point, we have, you can see that the control panel executable file, spawn up run DLL file. And if you can see, look at run DLL file is also used to run, you can see msword.inf. So when we open that document, certain files were dropped, were downloaded on the disk. One of them is msword.inf file, right? And you can see this is a point where run DLL spawn out cmd.exe, right? You can see that. Then if you look at the command, you can see that cmd was used to spawn up the window app, what's it called, the window app calculator application, which is calc.dll, guys. So this is also depicting a malicious behavior, right? You can see there are several, and shows that it's happened twice. That's why we have, of course, we have the calculator application opening twice, as you can see from this event, right? So guys, so these are malicious behavior. This is what we can see from the process monitor. So like I said, I would like to also filter for, so let's close the process monitor. This is giving us some IOCs, giving us some indicators that we need to establish. We need to further check and investigate, for this malicious document. So if we go on to filter for, to add another filter. So this time around, we are going to be adding another filter to check for operations. That is where we have the operations column, if it contains any TCP. So the aim is to check if there's any external connection, connectivity to a CNC server at the point of opening that document. So if we do this, we're just going to wait for a while so that we can check through the process monitor event. So guys, these are some of the behaviors of this 0-day that we need to take note of. So like I said, events where we have winword.exe spawning up, cmd, run DLL, and we are seeing run DLL also, opening up, what's it called, the window application. DLL file. So these are events that shows that are malicious, that are indicators that we need to further investigate what is happening with this malicious file. So if we also go on to check, like I explained, so you can see following the attack key chain for this 0-day malware, we can see that at this point we noticed that yeah, so we noticed that we saw a .ini file, as you can see, right? So that is what the malicious ActiveX Control will do. If you download the .cab file, that we saw, you can see the .cab file. It's request for the .cab file. Then once it gets the .cab file, right, from the remote site, which is our command and control, then it's going to extract the .ini file, which we saw at the time from the process tree, right? So, and the .ini file is actually a DLL file. So we noticed that the .ini file was actually executed using run DLL. So because the ActiveX control cannot execute the .ini file directly, it needs to spoon up the run DLL file to do this, right? So that is what we saw from the process monitor. So let's take a look at this event. So guys, you can see at this point, we're also able to establish that there was there are several external communication requests that was made at the point of opening the winword document. You can see, I don't know if my screen is large enough at this point, so I'm just trying to make sure that you guys can see the request. Let me try to expand. So you can see, guys, first of all, let me scroll up. So there was TCP connection request that was made from the target machine when the Word document was open. So it was made to the CNC server, an HTTP request. Then you can see several responses, right? So this just shows us that there was a request a request that was made to an external CNC server when the document was open, right? So at this point, let me just do this and click apply. So let's take a look at some other activities that we're able to discover. For example, if there's a creation of certain files like MSHTML file, right? So you guys, you can see. Okay, so we can see several. You can see. So we're trying to look out for events, some other events apart from. You can see there was a TCP connection request that was made, right, to the CNC server. This point. Okay, yeah, so you can see this is the IE frame.ele file. Is a dynamically library file that is commonly used by the Internet Explorer, to host web pages too. So I'm just trying to scroll down to see if we can discover any unusual activities apart from what we've seen so far. And look at, it's taking some minute. Yeah. Okay, and do this. Okay, guys, you can also see that we notice that you can see at this point we noticed the .cab file. You can see at this point, just like we saw during our attack key chain, that the malicious ActiveX will download the .cab file, and this is what we can see. So these are some of the indicators. So when we open, for example, a malicious document, and we are seeing that .cap file, this is read operation. At some point, you can see the create file, creating .cap file, right? So because once the .cap file was created from the remote side, then it's going to extract the INI file, the INF file. So at this point, this is where it creates the .cap file, right? So once we can see, then after creating, then start reading the file to extract the .inf file. Okay. We can go on and on to start looking out for IOCs regarding this zero-day malware. Trying to scroll to look out if we can see any other unusual behavior. We can see activities around the .cabinet file. Yeah, you can see so many events around the .cabinet file. Yeah. So I also want to take a look at if we can filter for where the part contains, for example, let's see, part contains, take a look at MSHTML file. So let's take a look at if we can get something from okay. Okay, guys, so you can see that at some point, you can see that, yeah, you see after creating a connection, connectivity request to the CNC server, we can see that there was a load operation for the MSHTML. So this, at this point, this is what, like I was saying, if we take a look at, so using the, take a look at the architecture once more. So like I said, the MSHTML file is where the vulnerability exists, right? Because this is commonly used, is Microsoft proprietary browser engine for Internet Explorer, and it is used to render pages, right? To display web pages, right? So at this point, this is where malicious users or attackers try to create or craft a malicious ActiveX control, which is the ActiveX control is embedded within the MS-HTML, and it is used to also, like you said, deliver web pages. But attackers can create a malicious ActiveX control and insert it within a Microsoft document, like I said, delivers it to the user via phishing attack, so that once user opens it, the user will be able to establish connectivity to a CNC server and download several other malwares that can be used to infect the target machine. So as you can see that from the activities, there was a load operation. So this request is to load the winword.exe was to tries to load the MS-HTML file, at this point to view this web content. So at the point of opening the document, this is when the winword tries to load the ms.html dynamically library file, as you can see, and so that there was a create file request, right? There was also a read file request around this, right? So guys, these are just some of the details we can see and see within the process monitor, showing us the parent process, the child process, and giving us, like you can see, winword being the parent process, spawning several child processes, the control panel, the run DLL, and if we drill down further, we can see that at some point CMD was also triggered, right? We can see CMD at this point that was triggered, right? Then we can see what we the window calculator application That's why we have this application open here. So this is how this zero-day malware kind of work. So in the real life scenario, attackers will be using malicious payload, could be ransomware, it could be various Trojan or rootkits, that will run at the background of that victim's machine, right? So this is just how it works. So let us take a look at some security controls that we can put in place for this vulnerability, right? So if we go back to some of the mitigation process from Microsoft is that ActiveX Control should be disabled. So disabling the installation of ActiveX Control within Internet Explorer, mitigate this attack, right? So within the organization, what we can do is you can disable the ActiveX Control, at the network level using group policy, but for individual systems, what we could use, so for if you just have your individual systems, like to mitigate against these zero-day vulnerabilities, we could create a TSC file and copy. You can visit Microsoft's website, then you can copy these, create a TSC file on your system, guys. Just create a TSC file, and you're going to save it as with an extension of RGE. So we're just going to create a TSC file first of all. Then we're going to save our contents in it, guys. Then we're going to save these, save it. We are going to change the extension from TST to RGE.reg. RGE. Yeah. So guys, this is it. Then from what Microsoft has instructed us, you see, you're just gonna double click the .reg file to apply it to the policy hive. Then after that, you're going to reboot the system. So this is how to mitigate against this zero-day vulnerability for individual system, but within your network, enterprise network, it is advised, we are advised to disable the ActiveX Control for the installation of ActiveX Control in Internet Explorer, right? So that once documents that contain malicious ActiveX Control are open, it's not going to run, right? So there are also other mitigation processes that we have here to disable preview mode in Window Explorer. So we can do this within the registry key, you understand? So we can go on to the registry key to do some modification within the registry key. All you need to do is to follow some of this process. On the other hand, this seems to be like a manual process. I would highly recommend that if you are using what's it called, endpoint security, like Mcafee has also released a note, like I think, but I was on the 10th, that was I think on Friday, last Friday, they released a note around this zero-day vulnerability, and they recommended that an extra signature file has been released that should be deployed. So if you're using for example, Mcafee endpoint security solution, you can deploy this signature file, that kind of contain the latest signature for this to control for this zero-day vulnerability. We can also take a look at some of the virus suitor to check if your antivirus or endpoint security solution is able to detect this. So if there are certain, you can see there are other endpoint current at the moment, endpoint security solutions that can't detect this malware, this zero-day exploit. So if you have a solution that is currently detecting this, all you need to do is to update your endpoint security to the latest patch and deploy it across your network. So guys, that is what we have for now, and thank you so much for listening. Yeah.